Okay, the other part of this lesson is how to rewrite a trig expression, and there's a few different things we can do here. So if we wanted to add two trig expressions and they are written as fractions, how would we do that? So let's look at this one. Sine theta over 1 plus cosine theta plus cosine theta over sine theta. So we want to add these together because we want to simplify this the best that we can. And in order to do that, we have to kind of be reminded of this. What if we had 1 over x plus 1 over y? We know that if we are adding things with different denominators, we need them to have the same denominator. So the first fraction has an x but needs a y, so we would give it a times y on the top and the bottom. And the second fraction has a y but needs an x, so we would give it an x on the top and the bottom. So rewriting this, it would become y over xy plus x over xy, and then combining it into a single fraction, x plus y over xy. So we're going to use that same exact idea here. We're going to look at the bottom here, look at the bottom here, and say that we need them to both have the same bottom, the same denominator. All right, so in the first fraction, it has a 1 plus cosine theta, which I'm going to keep kind of in a parentheses because that's kind of the entire bottom. But it doesn't have a sine theta, so it needs a sine theta. So we're going to put a sine theta on the top and a sine theta on the bottom. Now on this next one, it has a sine theta, but it doesn't have the 1 plus cosine theta. So it's going to get 1 plus cosine theta on the bottom and 1 plus cosine theta on the top. All right, let's see now. We can rewrite them both and combine anything that we can. So this left one will be sine squared theta over sine theta 1 plus cosine theta. Over here we're going to have, let's see, cosine theta plus cosine squared theta over sine theta 1 plus cosine theta. So we successfully made the bottoms match, and once they've matched, now we can put them together, which is exactly what we're going to do. And let's see here. Sine squared theta plus, I'm going to swap those two, cosine squared theta plus cosine theta, all over sine theta 1 plus cosine theta. And I don't know if you see this, but I see it right here, sine squared theta and cosine squared theta. I'm going to kind of ignore that for a little bit, but I want to be reminded of this identity, which is sine squared theta plus cosine squared theta equals 1. So I can replace this part with a 1. 1 plus cosine theta over sine theta 1 plus cosine theta. This is actually working out really nice because now this entire portion can be canceled out right here. And this will simplify to be 1 over sine theta. And we know 1 over sine theta is actually cosecant theta. So it took a little bit of doing, but we were able to simplify that one pretty well. So we can add two expressions. Sometimes it'll work out nicely and everything will simplify, or sometimes it will not, and we just have to do the best we can and get it into a single fraction. Now, what if we're looking at something that is in a fraction form and we don't want it to be in a fraction form? Because sometimes the fraction form's better, but it isn't always. Let me put down another example for you. So, this one's going to be 1 over 1 plus sine x. And we don't want it in fraction form. For whatever reason, it's not the ideal form. So what we can do here is to actually multiply by the conjugate pair of the bottom. Okay, if the bottom was just a single term, it wouldn't be as much of an issue. We could kind of distribute it, do some things with it. But because it's a binomial, because there's a plus sign here, that kind of limits us. So the best way to get rid of that is to multiply by 1 minus sine of x. And remember, to keep this mathematically the same value, I have to multiply the same thing on the top and the bottom always. Now, by multiplying by conjugate pairs, 1 plus and 1 minus, the middle terms are going to cancel, and this should work out very, very nicely. So on the bottom here, we're going to get 1 times 1 is 1, 1 times negative sine x plus sine x, and minus sine squared x, once I FOIL that. And then the top is just going to be 1 minus sine x. Alright, on the bottom, the negative sine x and the positive sine x cancel, just like we wanted. And I now have 1 minus sine x over 1 minus sine squared x. Well, I'm going to see what I can do with that. And as soon as I see that sine squared x, I'm going to think of that Pythagorean identity, same thing. Sine squared x plus cosine squared x equals 1. Well, what if I subtract the sine squared x over there? I'm going to get 1 minus sine squared x. So let me show you what I mean. Cosine squared x equals 1 minus sine squared x. So I see now I can replace the denominator with cosine squared x, which is what I'm going to do. 1 minus sine x over cosine squared x. Now that I got the denominator down to a single term, I can now do a lot with this. I'm going to actually distribute the division of cosine squared to both terms in the numerator. So I'm going to have 1 minus cosine squared x minus sine x over cosine squared x. And I will be able to simplify each of these terms individually. So 1 over cosine squared x will just be secant squared x. That one's easy enough. This part, however, let's see, sine over cosine is tangent, but I have an extra cosine, so this is technically this portion. I'm just focusing right here. This is going to be sine x over cosine x times 1 over cosine x. So if I take that cosine and I put 1 with the sine, that one's creating a tangent. So that's a tangent x. And then this one's creating another secant, so tangent x, secant x. Now, agree to disagree, you might believe that the original part was simpler and nicer looking, but in some cases maybe we cannot have a fractional form of one of these expressions. So if need be, we can change it. Alright, so for this I have 3 more that I'd like you to try, and they would be on page 360. Let's see, 57, 59, and 61. Oops, I messed up. Not 57, 59, and 61. 61, 63, and 65. That's what I meant. 61, 63, 65. Okay, so try out those 3. Try out the 3 from before, and let me know if there are any questions. Thank you.